Hi members. So welcome for today's class. Welcome for today's class. Now today we'll be doing networking, that's for QA. For those who are their first time, that means they are joining the Zoom. So Kaida, you know how to use it? You know how to use it? Join with the audio so that you can be able to hear me clearly. So for today we'll be doing network analysis. That's what we'll be doing. And then before I forget, remember tomorrow we have an auditing class with Mr. Japheth starting from 8:30. Also, Monday being a holiday, because QA you have some topics which are wide. So I want us to fix a class on Monday being a holiday. So we'll have a class from 4 to 6. So kindly note that. I'll still be continuing, even in case I'll not be able to finish what I'll be doing today. So I'll finish on that day and then we take another topic. So for today, we'll be doing network analysis. Network analysis is one of the sensitive area for QA, highly examinable. And now network analysis, it's all about evaluating a project. Assuming you are given a project, how can you be able to link up some activity and events? So network analysis, it's all about a mixture of how you are going to carry out activity and events. So we'll come to know what's an activity, what's an event. Then for network, it's classified into majorly we have two parts. Number one, we have the critical path analysis. Then we have what you call the path technique. Now CPA, or the critical path analysis, will be used where we are certain. Then for path, or what we call the project evaluation and review techniques, in that case, we'll be using them whenever we are uncertain about the project. Whenever you're saying we are uncertain, we mean that we are not sure about the time you're going to take to complete a given task. So under CPA now we'll look all about the frauds, things to do with frauds, also crashing, also how to do the Gantt chart, and also how to draw the Gantt. So one of the requirements for network classes, whenever you're doing an exam, whenever you're in my class, you need to be having one bob, the small one bob or the 5 bob, because we'll be using them to draw. So first of all, now let's go to the whiteboard so that we can be able to discuss some things there. So we are doing the network analysis, and starting with the definition, a network analysis is a set of integrated technique for the project management using activities and events, So that means network analysis will be majorly focusing on activity and events. We'll come to see what's an activity, what's an event. Then we have some terminologies here. We have what we call the float. Now, float is the time through which an activity can be delayed without affecting the actual project time. And for the critical activities, float is always equal to 0. So I repeat again that float is the time through which an activity can be delayed without affecting the actual project time. Then what's a project? Now a project is a human undertaking which consists of series of interrelated tasks and consume resources. That's the project. Then I want us to come here to activity. What's an activity? An activity. Now an activity is a human task which consumes resources. Also we have the events. What are events? Now events is the start and the end of an activity. And then we have what we call a dummy activity. Now a dummy activity, it's something like an activity which does not consume any resources nor time. So that is it. So this is what I mean. So yeah, looking at the network analysis. You're looking at network analysis. So in network analysis, these I'll be dealing with them. So we'll be having things to do with like that. You are moving from one point to another. Now, this is where you are starting. You start, and this is where you finish. Now, you can call it 1. You are moving from 1 to 2. Also, this one can call it the head. This one is the tail. And then moving from 1 to 2. Now, this is what we call an activity. And we have said an activity is an undertaking which consumes time and resources. Moving from 1 to 2, we'll be having what we call the duration. Now, the start and the end, now this is what we call event. Also, this one is the event. We have said that an event is the start and the end of an activity. So, but the activity itself is this one, the movement from activity one, from event 1 to 2, now that's what we call an activity. Then you can see all my events are classified into 2. So now this is where you are starting. So in this case, we have what we call, this is what we call the earliest start time, the earliest start time. This is what we call the latest start time. We come here to note number 2. This is what we call the earliest. Remember, this is the finish. The earliest finish time. This is the latest finish time. You are starting here. This is the finish, or that's the end. So you have said that this, we have divided them into 2. So this is the earliest start time. This is the latest start time. You come here. This is the earliest finish time. This is the latest finish time. So with that, we got to analyze or getting what we call the fruit. Now, sometimes we taught to get the fruit. How do you get the fruit? How do you get the fruit? Let me take you back. We have 3 types of fruits, and we have said that fruit is the time through which an activity can be delayed without affecting the real project. So in this case, we have what we call the free fruit. We have what we call the independent fruit, and we have what we call the total fruit. So number 1, we have what we call the free fruit. Then we have what we call independent fruit. And if you combine the two, you'll get what we call the total fruit. Now, how do you determine the free fruit? Now, free fruit in layman's language is the amount of time which an activity can be delayed without affecting the subsequent activities. This one we are dealing about the subsequent activities. And this one you take the earliest finish time minus the earliest start time minus the duration. That's how we get the free fruit. The earliest finish time, you minus the earliest start time minus duration. Then for the independent fruit, fruit in layman's language is the amount of time which an activity can be delayed without affecting the space-time of either the preceding or the subsequent activity. So this is how we get the independent. You take the earliest finish time minus the latest start time minus the duration. The earliest finish time, latest start time minus duration. Then we have the total fruit. Now the total fruit is the most important. I want you to note the total fruit. Now the total fruit, this is how we get the total fruit, is the latest finish time minus earliest start time minus the duration. And we have said that total fruit, or the fruit, is a time through which a project can be delayed without affecting the entire project completion time. Then one thing you need to note that NB, for critical activities, you'll come to know what are the critical activities. For critical activities, fruit is always equal to 0. That means you cannot delay that activity. So that's just an introduction for the analysis for that. Yeah. So now let's go to, we do an illustration. We do an illustration on how to show this. So you can take out your past paper, December 2011, question 2A. December 2011, question 2A. December 2011, question 2A. So that's the question. That's the question. You are told that ABC Limited has been awarded a contract for renovating office block of XYZ Limited. The chief architect of ABC Limited has provided the following information relating to the contract. information relating to the control. So you are given the activities, then you are given the normal time, and then you are given the manpower requirement required. Number one, they want a network diagram for the above project. And number two, they want the total float for each activity. So how do you draw that? So if we start with number one, the network diagram for the above project. So in this case, what you'll be doing, whenever you're drawing a network, always start with a sketch. You'll be starting with a sketch, and this is how we sketch. I've said that we'll be starting with a sketch, and this is how we sketch. We want to draw the network. So kindly let's be here. We are told that we have the activity here, 1 to 2, 1 to 2. So it's 1 and a pair 2, 1 and a pair 3, also 1 and a pair 3, 1 and a pair 4, 1 and a pair 4. So it's 1 and a pair 4. Then 2 and a pair 5, 2 and a pair 5. Then 3 and a pair 5, 3 and a pair 5. Then 4 and a pair 6, 4 and a pair 6. Then 5 and a pair 7, 5 and a pair 7, 5 and a pair 7. And then 3 and a pair 6, you see, 3 to 6. So 3 and a pair 6, and then 6 and a pair 7, 6 and a pair 7. Now that's how it will look like. So that's the sketch. So allow me now to draw. Allow me to do it now. So already having the sketch, now we can draw it. Here we had activity 1, we have 2, we have 3, we have 4. That's why I've said that in an exam you need to be having a coin. Then we have 5, we have 6, we had 7. It's just that one I'm drawing. So then you divide it by 2, the earliest and the latest. Then 1 walikuwa amepea 2, 1 and a pair 3. So this is 1, this was 2, this is number 3, this is 4, this was 5, this is 6, that's number 7. Also 1 and a pair 4, and a pair 5. It was like that. Then you need to show the arrow, the direction they are moving. So this was a sketch. So now this is the fair copy. Also, from the question, you are told that 1 to 2 it's A activity, 1 to 2 it's A, 1 to 3 is B, then 1 to 4 it's C, then 2 to 5 is D, then 3 to 5 is E, 3 to 5 that's E, 4 to 6 is F, 4 to 6 is F, 5 to 7 is G, 5 to 7 that's G. Then we have 3 to 6 H, 3 to 6 is H, and lastly 6 to 7 I, 6 to 7 it's I. To include that, now you can include the time now. You see the normal, you had the normal time. Activity A was 1. Activity B was, we had 3. Activity C, still 3. Activity D, 1. Then activity E was 2. Activity F is 5. Activity G, it's 3. Activity H is 4. And lastly, activity I is 2. So now, so that's the sketch. So kind of, if you want to concentrate, if you have them, I'll be posting my past paper. Don't draw this. I'll share the notes. I'll share everything. So don't worry. In case you decided to copy, you'll float. Not unless you screenshot or get the important points there. So I'll share the notes. I'll share everything. So kindly don't copy. So now let's be here. Let's be here. So now, how do we fill this? How determine the earliest and the latest? Now, in this case, we have what we call the forward pass, and then we'll be performing what we call the backward pass. The forward pass. Now, for the forward pass, we'll be concentrating on filling the earliest. That's the forward pass. For the backward pass, we'll be focusing on filling the latest. I repeat again. For the forward, you fill it in the earliest. For the backward, when you're moving from node number 7 to node number 1, you'll be filling the latest. And this is how you fill. This is an activity. You are starting at activity A. That's time 0, 0. From 1, you go to 2. This is how you do it. It's 0 plus 1. Here you took 1 week. So 0 plus 1, you get 1. Then, from 2, we go to 3. 3 ametoka hapa kwa 1. It was 1 to 3. So it will be 0 plus 3. You get 3. From 3, we go to 4. 4 alikuwa ametoka hapa. So it's 0 plus 3. You get 3. From 4, we go to 5. Now, one thing you need to know that 5 has 2 incoming variables. Whenever has 2 incoming variables, take the highest time. You take the highest time. So it will be, this remember it was 1. It's 1 plus 1 is 2. Also has this one, this one is incoming. So it will be 3 plus 2, you get 5. So 1 plus 1 is 2. 3 plus 2 is 5. You take the highest. So in that case, you get 5. From node number 5, we go to node number 6. Also, node number 6 has 2 incoming variables. The 2 incoming variables. You take the highest. This is what I mean. 3 plus 4, you get 7. Also, you have another incoming variable. 3 plus 5, you get 8. So the highest is 8. So it has 2 incoming variables. So it will be 3 plus 4, which is 7. And then also another incoming variable, 3 plus 5, which is 8. You take 8. From 6, now you go to 7. So you go to 7. 7 has 2 incoming variables. So how do we get that? You take the highest. So it will be 5 plus 3, which is 8. Also, you have another incoming variable, 8 plus 2, which is 10. So you take the highest, and the highest will be 10. At itakuwa 10. Note that the first node and the end, they should be the same. This is 10, this is 10. So now that's how you perform the forward pass. I summarize it again. I say that whenever you're getting the forward pass, just fill in the earliest. And then, assuming, like for example, number 5 has 2 incoming variable. You take the one with the highest time. Like this one was 1 plus 1, you got 2. This was 3 plus 2, you get 5. So you take the highest, which is 5. So you fill up to this point. Now, I want us to perform the backward pass. Now, the backward pass is the vice versa. From node number 7, we are going backward. We go to number 6. So it will be like this. 10, in this case, we're looking at the latest. 10 minus 2. 10 minus 2, you get 8. From node number 6, you go to node number 5. 5 walikuwa ametoka hapa. You are going backward. So it will be 10 minus 3. And you'll get 7. Then, from node number 5, ukirudi nyuma unaenda kwa node number 4. You remember you are going backward. 4 alikuwa amepea huyu. So you are going back to 4. So itakuwa 8 minus 5. Not this 8, but this one for the latest. So it's 8 minus 5, you get 3. From 4, you go to 3. 3 alikuwa amepea wawili. You see? 3 amepea wawili. Now, whenever you are performing the backward pass, kama amepea wawili, you take the lower one. When performing the forward pass, you take the highest. Backward pass, you take the lowest. This is what I mean. So like in this case, you'll take, like we are dealing with node number 3. Alikuwa amepea wawili. So it will be 7, not 5. It's 7, the latest. 7 minus 2, you get 5. Also alikuwa amepea huyu. So it will be 8 minus 4, which is 4. So you take the minimum. So 7 minus 2 was 5. 8 minus 4, it's 4. So the list is 4. Then from node number 3, we go to node number 2. 2 had already given 1 as one outcoming variable, so it will be 7 minus 1, and you'll get 6. Then from 2, you go to 1. That one is 4. So now that's what we call a network diagram. Now, after draw the network diagram, we have to consider what are the critical activities. Now, critical activity, they are those activities you cannot tamper with. You need to focus your all your resources there, all your time there. And in this case, we identify what we call the critical path. Now, this is how we get the critical path. Umeanza 1, you can go to 2, you can go to 3, you can go to 4. You have 3 routes there. Now, this will determine the critical path. From, if you go to 2, you have 1, 6. That one is not critical. 3, 4 is not critical because they are not the same. But here we have 3, 3. If they are the same, that one becomes the critical activity. You do it like that. Now, from 4, you see from 4, you go to 6. You see 8, 8. It's another critical path. From 6, you see when you meander. So in this case, 8, 8, 10, 10. We have that. Now, this is what I mean. The project duration, that means you'll complete your project. You see, it was 10 days. Then, what are the critical activities? Now, critical activities, we have seen we have C, also we have F, and then we have I. C, F, I. And if you want to know the critical activity, this is what you can do. It's 0 plus 3, which is 3. 3 plus 5 is 8. 8 plus 2 is 10. I hope you are getting that. If you take this one, 1 plus 1 plus 3 is not 10. But for the critical, if you add the critical activities duration, you should get up 10. Then, critical path, if you want to show the critical path, it's C to F to I, or you can show it like this. 1, you go to 4, you go to 6, and then you go to 7. So that was the project duration, last 10 days. Critical activities. Tumesema for critical activity, you start from here. You'll be looking at the earliest and the latest. If they are the same, that one forms the basis of the critical. So that's 3, 3, 8, 8, 10, 10. That means you follow that route. So part B of the question. Now the part B of the question, they were asking about you determine the float. Yeah, the total float for each activity. Total float for each activity. How do you determine the total float? How do we determine the total float? How do you determine the total float? So in this case, I don't want to have that. So allow me to put it here. I'm doing part B. So we have the activities here. We have activity A, B, C, D, E, F, G, H, and I. Then, kindly allow me to write it, the formula here. Allow me to write the formula here. We said that total float, you take, how do you get the, that one? We said you take the latest finish time. Said we take the latest finish time. So you'll take latest finish time minus the earliest start time minus duration. That's how I'll be getting the total float. I repeat again, latest finish time minus earliest start time minus duration. So this is what I mean. If you're moving for activity A from 1 to 2, now this will be the earliest start time, latest start time. Earliest finish time, latest finish time. I repeat, for activity A, this is the source, starting, finishing, starting, finishing, starting, finishing, starting, finishing. It will be like that. So in this case, we are moving from 1 to 2. So this is the start, this is the end. So this is the earliest start time, latest start time. Earliest finish time, latest finish time. So for you to get the total float, we have said that you take the latest finish time, this is the latest finish time, minus the earliest start time, This was the earliest start time minus duration. In short, just do like this, like this one. Chukua ya mwisho, right, left, 6 minus 0 minus 1. Unakuja hapa. This is the latest, this is the earliest. So like for A, it will be 6 minus 0 minus duration. Tukue umechukua 1 and you get 5. If you go to B, tumesema is the latest finish time, which is 4, minus earliest start time, which is 0, minus duration, which is 3. And you'll get 1. If you come to C, ni he, right, left. So it will be 3 minus 0, and the duration was 3. And you'll get a 0. So D, now tuende kwa D. D, it will be like this, D ni he. The latest, the earliest. Mwisho. So it will be 7 minus 1, and the duration was 1. And it will get 5. So kindly do for me E. Do for me E, and you post the answer there. Do for me E. I just want you to give the final answer. So this is the activity E. So how much will be the answer? So compute that. I see if you are following. Yeah, you are doing for E. I can see 2, 2, 2. 2. Correct. It's 2. Yeah, because this is what we are doing. Here mwisho, which is 7, minus the earliest, which is 3, minus duration, which is 2. You get 2. F, here we have F. So itakuwa 8, 0, 5. So it will be 8 minus 3 minus 5. You get 0. Let's go to G. Here we have G. So it is here mwisho, he. So it will be 10 minus 5 minus duration of 3, and you will get 2. H, here we have H. H will be 8 minus 3, and the duration was 4, and you will get 1. Lastly, we have I, 10 minus 8 minus 2, and you'll get what? 0. There is something we said, that the total fruit for critical activities is always equal to 0. That means, remember we said that the fruit, okay, let me take you back. Like A, the fruit is 5. That means for activity A, you can hold it for 5 days. 5 days without kufanya kazi, but still you'll complete your project within 10 days. So that means you can delay project A for 5 days. Remember we said that float is the time through which a project can be delayed without affecting the project completion time. Project B, this project B, you can delay it for 1 day. C, it's 0. Remember C, you see C is a critical activity. We say that you cannot delay critical activities. So we say that total float for critical activities is always equal to 0. D, you can delay it for 5 days. E, you can delay it for 2 days. F, 0. That means F is a critical activity. You see where it is? It's part of critical activities. G, you can delay it for 2 days. H, for 1 day. I, you cannot delay it because I was a critical. Good. So now let's try another question. Now we go to part. If the project duration is uncertain, how can we draw that? If the project is uncertain, how can we come up with that? Now, whenever you're dealing with uncertain project, now for uncertain projects, this is when you are not sure about the time. Now that's what we call the project evaluation and review techniques. In this case, the project you're dealing with is uncertain. You are not sure about the actual completion time. So in that case, this is how we determine that and a part. In that case, how do we determine the expected time? Now, for the expected time, this is what you do. you take A plus 4m, it's a formula, plus B, you divide by 6. Then, how do we get the variance? The variance is B minus A divided by 6, all of it you square. What does that mean? What's A? What's M? What's B? Now, A is what we call optimistic time. Optimistic time. That means the shortest time you can be able to complete the project. M is the most likely time. And B is the pessimistic time. Pessimistic means that the longest time you can take. Optimistic is the shortest time you can take. Most likely, that's the average. And B is the pessimistic, the longest. So this is the shortest, this is the longest. Now, in that case, for part, in case you're not sure about the project, that's how you get the expected time. A plus 4m plus B, you divide by 6. For you to get the variance, you'll take B minus A, divide by 6, then all of it you square, where A is the optimistic time, M is the most likely time, and B is the pessimistic time. Good. So now let's try an illustration. Let's do an illustration on that. Illustration on that. So we can do for December 2012, question 4C. December 2012, question 4C. December 2012, question 4C. So we can go through that question. We are told that the following data relates to a certain audit assignment of a certified public accountant firm. So we have the activity, then we have optimistic time in days, so that one becomes A. Then we have the most likely time in days, and then we have the pessimistic time in days. Required a network diagram for the above audit assignment. Then number 2, the critical path. Then number 3, the standard deviation of the audit assignment, and then the probabilities that the audit assignment will be completed within 55 days. So we have said that step number 1 is for you to come up with a sketch. So sketch is the most important thing. And how do we draw a sketch? How do you draw that sketch? So I want me to draw that sketch. So 1, I'm a pair 2. So it's 1, I'm a pair 2. Then 1, I can pair 3. Like that. Then 2, I can pair 4. 2, I can pair 4. 2, I can pair 3. 2, I can pair 3. Then 3, I can pair 4. 3, I can pair 4. 3, I can pair 5. 3, I can pair 5. 4, I can pair 5. 4, I can pair 5. 4, I can pair 6. 4, I can pair 6. 5, 6. 5, 6. 5, 7. And then 6, 7. Now that's how it will look like. And then 1 to 2, it's A. 1 to 3 is B. 2 to 4, C. 2 to 3D, 3 to 4E, 3 to 5F, 4 to 5G, 5 to 6I, 4 to 6H, 5 to 7J, and 6 to 7K. So that's how it will look like. But now before we draw, you see now, because for A we'll have to include the duration. Remember in this case, we are given the optimistic time, the most likely time, and the pessimistic. So for project A, B, C, D, remember we have to indicate the project, like A, assuming 10. How do you get that 10? So in this case, we use the formula to get the expected time. So, and how do we get that? So we need to use that. So allow me to compute on that. So we had activities here. Then we have said that how do we get the expected time? So expected time, we have said it's A plus 4M plus B divided by 6. Then also we can get the variance. We have said that for the variance, you take B minus A, divide by 6, and then you square. So we have activity A, B, C, D, E, F, G, H, and then I, J, and K. So how do we get that? For example, for A, this is how we get the expected time. For A, remember the optimistic, this one will present. Optimistic will represent A. So in that case, it will take 3, 6, 4, 8. Then we have 5, 5, 4, 3, 6, 6, 6. Now those are A. Then you add. You are adding 4M. So it's 4M. You multiply by M. And we have said that M is the most likely time. M. So in this case, we are given the most likely. We have the most likely here. So like this one will be 6, 7, 8, 10. Eh? So allow me to include that there. So it will be 6, 7, 8, 10, 8, 9, 7, 6, 11, 8, 8. Then you add B. So we said that it's A plus 4M plus B. So B, we said it's our pessimistic time. So in this case, we have the pessimistic time. So like, for example, the first one, it will be 12, 8, 15, 15, 11, 13, 10, 9, 16, 10, and 19. Then all of it, what you get there, based on our formula, you divide by 6. So compute the first one. I want the answer for the first one. And apply the rule of Bodmer's. So give me the answer, the expected time for activity A. Give me the answer for activity A. Yeah, it's 6.5, correct? So this will be 6.5. So this one will be 6, 8.5, 10.5, 8, 9, 7, 6, 11, 8, and 9.5. So now, this time is what you'll take to the network diagram. Now let's get the variance. Let's get the variance. We say that you take B minus A, our B. Remember our B was the pessimistic time, eh? These ones, this one, the B's we have added. So like this one will be 12, 8, 15, 15, 11. I'm taking this, eh? B 9, 16, 10, and 19. Then we minus A. Our A was the optimistic time. Hii tuliongeza hapa, the 3, 6, 4. So you minus 3, 6, 4, 8, 5, 5, 4, 3, 6, 6, 6. Then what you get there, you divide by 6. You divide by 6 first. Then after you get that, then you square your answer. Can you do the first one and post your answer there? Yeah, correct. I can see it's 2.225. Yeah, the first one is 2.225, 0.11. This one will be 3.36, 1.36. This one will be 1, 1.78, 11, 2.78. This one will be 0.44. This one will be 4.69. So that was the first step. Whenever you are not given the actual time, you do that. Then from there, now let's draw the network diagram. Draw the network diagram. We already had the sketch. So if you have the sketch, now there was the sketch. So allow me to draw the fair copy. And then unaweka kofia kila mahali. So this was 1, this was 2, 3, 4, 5, 6, and 7. So we have that. So this is A, this is B. Then 2 alikuwa amepea 3, you show the arrow. D. And then another thing you need to note, now assuming the 2, you had just drew it above 3. So avoid drawing a perpendicular line. This is what I mean. Assuming 4 has given 5, don't draw a perpendicular line like this. Make sure it is slant. It's one of the rules when drawing networks. So kind of don't draw a perpendicular line. Make sure that it's slant, just as a retrace. Then we have that. That was C. That's E. That's F. Then 4 alikuwa amepea 5. So that was G. I have said that you don't draw a perpendicular line. Just make sure kame slant kidogo. Then we have H. We have I. This was J. And this one was K. Now, then we include the time. Like for A, what you have gotten here, the 6.5, the 6, after getting the expected time. Now, that's what we include here. Like for A, we've gotten it's 6.5. This is 6.5. B, it's 6. C was 8.5. D was 10.5. And then remember, for networks, they are not drawn to scale. You don't draw them to scale. That means that if this is 10, you draw it bigger than 6. No, 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 no. Then for A, it was 8. For F was 9. For G was 7. Then H was 6. Good. So now let's perform the analysis. This is why we are starting at node number 1, 0, 0. From node number 1, we go to node number 2. So it's 0 plus 6.5, so it will be 6.5. From 2, we go to 3. Now, 3 has 2 incoming variables. 3 has 2 incoming variables. Kuna D, and we have D. We have B. So we take the highest. Like this one will be 0 plus 6, which is 6. And then we have 6.5 plus 10.5. And that one you get 17. So you take the highest. So you take 17. From 3, we go to 4. 4 has 2 incoming variables. You take the highest. 6.5 plus 8.5, that's 15. 17 plus 8, you get 25. So the highest will be 25. So you take 25. From 4, we go to 5. 5 has 2 incoming variables. You take the highest. 17 plus 9, you get 26. 25 plus 7, you get that 2. So the highest is that 2. So you get that 2. From 5, we go to 6. 6 has 2 incoming variable. 25 plus 6, you get that 1. That 2 plus 11, you get 43. So the highest is 43. Then, from 6, we go to 7. 7 has 2 incoming variables. So it will be that 2 plus 8. That one will get, that one is 40. Then 43 plus 9.5. That one will get 52.5, which is the highest. So 52.5. Also, this one will be 52.5. Now, let's perform the backward pass. We perform the backward pass. So from 7, we go to 6. So you take 52.5 minus 9.5, which is 43. From 6, we go to 5. 5 had 2 outgoing variables. And we have said that whenever you're going backward, in case had 2 or more than 1, you take the least. So 52.8 minus 8, that you'll get 44.5. 43 minus 11, you get that 2. The least is that 2. So you get that 2. From 5, you go to 4. 4 had 2 outgoing variables. You take the minimum. So 43 minus 6, you get 37. Then we have this. That 2 minus 7, you get 25. So here you have that 7, we have 25. So the list is 25. From 4, we go to 3. 3 has 2 outgoing variables. So from there, you take the minimum. That 2 minus 9, in that case, you get 23. Then we have 25 minus 8, you get 17. So the minimum is 17. Then from 3, we go to 2. 2 had 2 outgoing variables. You take the minimum. So 25 minus 8.5, that means you get 16.5. Then 17 minus 10.5, you get 6.5. So the list is 6.5. From 2, you go to 1. So now that's the network. So now let's identify the critical path. So now, as you can see, 0, 0, 6.5, 17, 25, that 2, 43, 52.5. Zote zinafanana, But how do we identify the critical path? Now, let's look at this. So now, I want you to post your answer there. A, 6.5, and B, 17. Which one do you want us to select? So which one do you think will be the critical activities? So post your answer there, A or B. Penina, I can see A. Tuende kazi. Others, I can only see answer. Simi, I can see A. Agnes A. Charles B. Abdi B. Abdinaziz A. Christine A. Redemptor. I can see Galaxy, both. Now you have to select one. It's either you go to heaven, you go to hell. So now let's be here. In case they tie, this how you get the critical path. 0 plus 6, it's not 17. So where's BT here? Are you getting? If you take 0 plus 6 is equals to 6, but here you have 17. So that one is not critical path. 0 plus 6.5 is 6.5. That means utapitia A. From A, from 2, do you go to C or do you go to D? Now, let's look at this. Because you can go to 3, you can go to 4. If you take 6.5 plus 8.5, it's 15. Is C 15? That one does not make sense. But if you take 6.5 plus 10.5, you get 17. So where the D? Now from 3, you can go to 4, you can go to 5. So if you take 17 plus 9, you get 26. This one is not 26. So that one makes no sense. 17 plus 8, you get 25. So utapitia here. Now, from 4, you can go to 6, you can go to 5. Now, let's test if you go to 6. So it is 25 plus 6, you get that 1. This is not that 1. 25 plus 7, you get that 2. So this is the correct way. And then from 5, you can go to 6, you can go to 7. So that 2 plus 11, you get 43. That means that's the correct way, because that 2 plus 8, that is 40. This is not 40. Now from 6, you unamalizia, because if you take 43 plus 9.5, you get 52.5. That means the project duration is equals to 52.5, I think they were weeks, and then the critical activity, we have A, we have D, we have E, we have G, we have I, and we have K. Critical path, it's A, D, E, G, I, K, or you can do this, 1 to 2, so it's 1, 2, 2 unaenda kwa 3, 3 unaenda kwa 4, 4 you go to 5, 5 you go to 6, and 6 you go to 7. So now that was part what? So the question was, number 1, the network diagram, we already have that. Number 2, the critical path, we already have it. Then the standard deviation of the audit assignment, the standard deviation. Now, let me take you back. What we had here was the variance of each activity. But in this case, the examiner wants the standard deviation of the project. So in this case, you just consider the standard deviation of the critical activities. I hope you are together. If you want to know the standard deviation of the variance for the project, you only take for the critical path. What you have gotten here is for each activities. So in this case, we'll do like this. We have activity A. Activity A had a variance of 2.25. So it will be 2.25. You add D. D is also critical. D had 1.36. Also, we had E. E had 1. Then we have G. G has also 1. Then we have I. I had 2.78. And also we have K. For K was 4.69. And the total you'll get 13.8. Now, this is what we call the variance of the project. But the examiner wants the standard deviation. To get the standard deviation, you just take the square root of 13.08. So that means the standard deviation will be 3.62. 3.62. Good. Then the last question was like this. That's part 4. The probability that the audit assignment will be completed within 55 days, 4 marks. The probability. How do we get the probability? How do we get the probability? Now, for the probability, let me take you back to the topic of probability theory. Now, to get the probability, that's number 4, you apply what we call the normal curve. Yeah, this is what we call the normal curve, ama kaugali. So the rule is that here we have the X bar, or the average, and here we have the standard deviation. Then it's usually divided into 2. This part is always 0.5. Remember, probability should equal to 1. This side, the probability is 0.5. And to get the probability is always Z is equals to X1 minus X bar. You divide by the standard deviation. Now that's how we get that formula. So in this case, our X bar is this project. The project duration was 52.5. So this was 52.5. We already have the standard deviation. The standard deviation is what we have computed here. The 3 point, you can see it here, the 3.62. So this is 3.62. So now let's get Z. Let's get Z. Now for Z, it will be like this. X1, so the question was like this. No, the question was the probability the assignment will be completed within 55 days. So 55. So now 55, is it on the upper side or the lower side? So 55 is on this side. So you can write it like there. So probability of completing within 55 days. So this is the area they want, within. So that means it's either between 0 to 55. If they have said more than 55, that's when you could have shaded this. So our x1 is 55 minus x bar, our x bar is 52.5. You divide by the standard deviation. Our standard deviation was how much? Was 3.62. If you do like that, what you get there, you should get 0.69. But that's not the probability. We read this one from the table. We read that one from the table. So how do we read this one from the table? So we have what we call the normal distribution table. Normal distribution table. Let me see if I have one with me. Yeah. Now, this is what we call the normal curve. How do we read the probability? Like in this case, we have gotten that 0.69. So you come here, 0.69, 0.69. You come 0.6, you have seen it, 0.69. So it's 0.2549. I repeat again, to get the probability of 0.69, it's 0.6 here, 9 should be always in two decimal places. So we have it there. So which is 0.2549. So this one is 2549. Now to get the probability, this is what you do. So what you have gotten here, 0.249, is the probability between 55 and 52. This one. It's only this, That's the probability between these. So that one is 0.2549. Then you add 0.5 because all of this, it's 0.5. And you'll get 0.7549. Now that's the probability of completing the project within 55 days. Or it's the same as 75%. You are 75% sure that you'll complete the project within 55 days. Good. So now let's look at another question. We look at another question. Someone is asking, must the answer be in caps? It's okay. A, it's A. Either big A or small a. So now let's start with let's try another question. May 2018, question 5B. I'm not doing that one. I just want to show you how to draw it. May 2018, May 2018, question 5B. So I'm hoping we are there. So I just need to show you just how to draw the network. About filling the time, don't worry about that. So we are told that the following information related to a certain construction project. We have the activity, we have the predeciding activities, then time in weeks. Most optimistic, that's our A. Most likely, that's M. Most pessimistic, most pessimistic. So in that case, remember we have said that the first step, even before doing the sketch, first of all, get the expected time. And to get the expected time, we have said that you apply the formula. So this is A, M, this is B. So use the formula, and you have said that the formula does not change. The formula was, you get 4A, or A plus 4M plus B. Yeah, this was the formula. So it's A plus 4M plus B, you divide by 6, and that's how you get the variance. So in this case, I am not showing you how to get that. I'm not showing you, you already know how to compute it. So here we have the answer. So you take A, plus 4 times m plus 12. Then you divide by 6, you get. Now what you get here, for example, A, it's 5, 14. Now this is what will go to the network. So my motive in this question, I just want to show you how to draw the network. So how do we draw the network? In case of this, this how we draw the network. This, I just need to show you how to draw the sketch. So how do we draw this? So in this case, this is not like the other one. That A amepea B, A amepea C. In this case, you are just given the activity and the predeciding activity. Now, in this case, pre means before. Pre means before. So that means this activity are the one giving this, pre. So these are the activity predeciding this. Like for example, this how I draw the sketch. This how I draw the sketch. Always start with the predeciding. So in this case, you are told that from the predeciding, we have 2 dashes. From the scratch, there are 2. You just draw 2 like that. This dash, I'm a pair A. The other one, I'm a pair B. Hope you're getting that. You start with the predeciding activities. Those that start from the scratch, you can see the dash. We have A, we have B. So, and in this case, you don't draw like this. That scratch, I'm a pair A, scratch, I'm a pair B. No, those are the activities. The other one, you are given that one, I'm a pair 2. Those who are the events, the start and the end, start and the end. Those are the activities. So from the scratch, there are 2, A and B. So we have A and B. Then A, you can see A, there are 3. A. That means A has predecided 3 of them. So that means A anapea watatu. 1, 2, 3. So amepea C, amepea D, na amepea E. C, D, E. Because it's A amepea C, A amepea D, A amepea E. Then BC wanawana. BC wanapea F. BC. So B and C. Hope you're here. B and C. So in this case, this is what you usually do. You can just interchange. Leta hii E, mpeleke huko juu. You take E there, then you bring C here. Because you should not cross over. So that B and C washikane wape F. To give F. To give F. Then D amepea G. D amepea G. D amepea G. Then unaambiwa E, F, G, they join hands, wanazaa H. So we have E, F, G. So we have E, F, and G. So all the 3, hii wote unawaleta pamoja. Wanazaa nani? Wanazaa H. That's how it will be. It will look like. So that means when you are drawing a fair copy, So how do you draw the fair copy from that? This is how you draw the fair copy. You need to be very strategic when you are drawing. So you have that. Then this one needs to be strategically located. Then we have that. Then we have that. We have that. We have that. So that's A. That's B. That's C. Then E. That's E. That's D. And then there we have G. Here we have F. And then ukaambiwa that E, G, and F wanashikana wakazaa H. So you need to be very strategic when you're doing this and this. Yeah. So we have said that if this one was, remember was E, this one was, you can still interchange them. That one has no problem. And then from that point, you just draw it. You go. Good. So now let's try another thing. So now this solution is already in your notes. I have already done it. So you just go and follow it. So now let's go to another thing. We go to another thing, what we call crashing. I want us now to deal with what we call the project crashing. Now, crashing, what do you think we mean by crashing? When you're saying now, like for now, we are doing the crashing program. So what are we doing? Now, crashing, in another term, just means taking the minimum time possible. Now, assuming you are given a task, that you are supposed to complete within 5 days. But then you are told that you need to complete it within 2 days. You see, you are reducing from 5 to 2. Now, that's what you call crashing. What can you do? Number one, to reduce the days. Now, assuming you are working alone, for you to complete within 2 days, number one, you can hire someone else, msaidiane na yeye kazi, or you can work overtime. So it's another thing you can do when you are doing the crashing. So now crashing, so we have some assumption made when crashing. If you are crashing, we have said that the time goes down, but you have to incur extra cost. So that's what we mean. So that's the crashing. They have said that crashing, we have to incur some extra cost. And then time and activity are usually always directly related. So now, let's look at that. Let's look at that. We have said that crashing involves taking the minimum time possible for you to complete the project. And we have said that whenever you are crashing, one of the assumptions is that, let's look at those assumptions. Assumptions made when crashing. Assumptions. Number one is the time and activities are directly related. And then time and cost are inversely related. What do we mean? Time and activity are directly related. That means the more activity you have, the more time you'll take. That means they are directly related. But time and cost, they are inversely related. We have said that crashing involves, you reduce the time so that you can complete faster. But in this case, we have said that if the time goes down, the cost will go up, because maybe you have to pay that person an extra amount for you to let's assume you are doing an overtime. Overtime actually comes up with an overtime cost. If you're hiring another person or personnel, you have to incur another cost. So that time and cost are inversely related. Then whenever you are crashing, how do you get the cost slope? Now, the cost slope is also known as the additional cost, because we have said that if the days reduce, the cost will go up. How do you get that change? Now, that's you get the cost slope. You just take the change in cost, you divide by changes in time. Now, let's assume you have an activity, and this activity A, the normal cost is 30. But if you crash, if you want to finish faster, it's like, for example, this is what I mean crashing. Assuming you have a construction project, and for this construction project, you usually employ 5 people or 5 workers. But now the owner has told you that I want this project to be completed within 2 days. What can you do? So instead of hiring 5, you can hire 10. So if you are paying them a salary of 500 per day, so what do you expect to pay 10 of them? So that means the salary will go up. That's what we are saying. So in this case, the normal cost was 30. And you have to crash. That means you have to employ more people. And the cost goes up to 100. And this case, the duration was 5 days. But if you crash, you can take just 3 days. How do you get the cost drop? We have said that the cost drop, you take the change in cost from 30 to 100. It has changed by 70. So it will be 100 minus 30. You divide by the changes in time from 5 to 3. So it's 5 minus 3. So it's 70 divided by 2, it's 35. What does this 35 mean? This means that for every day you save, you incur an extra 35. Every day you save, you incur an additional 35. Now that's what you call the cost slope. Good. So now let's do an illustration. We do an illustration. Let's do an illustration. Yeah, we are doing that question. So consider the following data below about a given project. Don't worry, the notes I have sent, it's already there. I've already included there. So consider the following table about a given project. We have activities, we have the predecessor there. Then we have the normal time, and we have the crash time. So this is the normal time, those are the crash time. Then you are told that you are given the activity cost slope. We have said that the cost slope is the additional cost you incur by every day you save. Required, the normal completion time and the critical activities. Then number 2, the shortest time to complete the project that can be completed. Now that means after you crash. Then the additional cost to be incurred if the project was crashed. We get the additional cost you have to incur. Then you explain the meaning of the cost slope and how it is computed. You have said that the cost slope is the additional cost. And how do we compute it? Is the change in cost over change in time. Then we have assumption made when crashing. We have said that time and activity are directly related, and time and cost are inversely related. So step number one, we have said that it's all about drawing a sketch. First of all, you draw the sketch. Here we have the activities, we have the predecessor, and I want you to follow this because this one is a special case. So always start with the predecessor. Pre means who, nani amepea mwingine. So in that case, you see from the scratch, we have 2 dashes. We have this and this. So that means you'll draw like that. There are 2. There are 2. This one, amepea A. The other one, amepea C. Then A, amepea B. A, amepea B. Then C, we have C. C amepredecide wawili. That means C amepea wawili. We have D and we have E. Then B, D, E wanashikana or wanaoana wanazaa F. B, D, E. So now let's be here. We need to be very keen. B, D, E. B, D, E. Now B and D, they can join directly. But you see, D and E, they are from the same parent. You see, D and E, they are from the same parent. That means they cannot intermarry. They cannot join directly. So what you do, because you are told that B, D, and E, they have to join for them to give you F. So what you usually do, you join using a dummy. Remember, I said that a dummy activity is an activity which consumes no time, no resources. Then we are told that B, D, E wanapea F. B, D, E. So B, D, but E cannot join directly because D and E, they are from the same parent. So that means you join them using a dummy so that wape F. Now that's how you draw the sketch. Then from there, we can draw a fair copy. So how to draw the fair copy here? Now this is how we draw a fair copy. Already we have a sketch here. Then, in this case, like part A, they're asking about the normal completion time. The other one, they're asking about the shortest time. So in an exam, you can draw the two separate diagram like this. The first one you analyze using the normal time. The other one you analyze using the crash time. Or a shortcut. Let me show you how you can do. You can just combine the two. You can just combine the two. In an exam, you can just draw the 2 of them, or you can just draw one, you combine the 2. So this is what I mean. This is what we are doing. Previously, this is what we were doing. But in this case, since we are doing the crashing, we have to, we have the normal time, we have the crash time. You can divide them by 2 like that. You divide by 2 like that. The upper side, you show the normal time. The lower side, you show the crash time. Then this was A. This was C. that was B, this was D, that's E, and then we have seen that E, to join with B, you draw using a dummy. A dummy show us a dotted line so that wakapea F. And Kaide do practice on this. This is topic that never misses. And then you may understand it here, but Kaide go and practice. What we have done, Kaide try to practice and draw them by yourself. Now, after I draw like that, now we are given the time. Let's start with the normal time. Like in this case, we are given project A, the normal time was 3. So A, it's 3, B was 6, C, it's 5, D, we have 8, E was 6, and F was 4. Damage is always 0. So now let's perform the forward pass 0, 0. So you can call it 1, you can call it 2, you can call it 3, 4, 5, and 6. So from here we go here. So from 1 we go to 2. So it's 0 plus 3, you have 3. From 2 you go to 3. So it's 0 plus 5, you'll get 5. From 3 we go to 4. So it will be 5 plus 6, which is 11. Then from 4, we go to 5. Now 5 has 3 incoming variables. Now for the 5 incoming variables, you take the maximum. How do you get the maximum? So in this case, it will be 3 plus 6, you'll get 9. 5 plus 8, you get 13. 11 plus 0, you get 11. So the highest is 13. So that's 9. This is 13. And then 11 plus 0, you get 11. So let me repeat again. We have said that dummy activity is an activity which consume no time. So for the dummy, it's always a dotted line. This one comes in whenever the two, when they are joining, it's not possible for them to join directly. Good. So this one we have said the maximum is 13. So 13 plus 4, you get 17. So this one is 17. So that means the normal completion time will be 17 days. Now let's perform the backward pass. For the backward pass, it's 17 minus 4, you'll get 13. From 5, we go to 4. So it will be 13 minus 0, you'll get 13. From 4, we go to 3. 3 alikuwa amepea wawili. You see, has two outgoing variables. So it will be 13. We are looking at the latest. It is not 11. We are saying when we are going backward, we deal with the latest. So 13 minus 6, in that case, you get 7. 13 minus 8, this was 8, you get 5. So the minimum is 5. So this is 7, this is 5, you take 5. From 3 we go to 2, 2 alikuwa amepea moja, so it will be just be 13 minus 6, of which you get 7. So that means the critical path, this is not critical path, this is 5, they are the same. Then 5, you cannot go those routes, they are not the same, but they are the same. So 5, 13, and then 13 and 4, you get 17. So that means if you take 5 plus 8, you get 13, plus 4, you get 17. So the normal completion time is 17 days. So normal project time, it's 17 days. Number B of the question was this. Number B was the shortest time the project can take can be completed, the shortest time. So how do you get that? So in an exam, let me repeat again. We say that you can draw this one as just one. You don't divide by 2. You just show us a normal table. Then you go to part 2. You draw another one. But in that case, hautakuwa divide by 2. So now, how do you get for the crash? For the crash, this is what you'll do. You are given the crash time here. You're given the crash time. For example, A is 3. So I'm showing it in red. Nimeonyesha huko juu. Then B was 4. Then C is 3. D is 7. E is 4. F is 2. Is 2. Then from there, now let's perform the forward pass, 0, 0. So in this case, we are doing the crashing. So I'm only dealing with the red. So it will be 0 plus 3, which is 3. From 2, we go to 3. So it will be also 0 plus 3, you get 3. From 3, we go to 4. So it will be 3 plus 4, you get 7. From 4, we go to 5. 5 has 3 incoming variables, So we take the maximum. So it's 3 plus 4, which is 7. Then we have 3 plus 7, which is 10. And then we have 7 plus 0. Remember that it's always a 0. So in that case, 7 plus 0 is 7. 3 plus 7 is 10. 3 plus 4 is 7. So the highest is 3 plus 7, which is 10. Then from 5, we go to 6. So it will be 10 plus 2. You get 12. So that means if you crash the project, the minimum completion time will be 12 days. So the minimum project time is equals to 12 days. That means you have already saved 5. So now let's perform the backward pass. 12 minus 2, you get 10. From 5, we go to 4. So it will be 10 minus 0, which is 10. Remember that it's always a 0. Either you are crashing or the normal. And then from 4, we go to 3. 3 has 2 outgoing variables. You take the minimum. So it will be 10 minus 4. Remember when you're going backward, we are looking at the latest, not the earliest. We're looking at the latest. 10 minus 4, you get 6. 10 minus 7, you have 3. So the minimum is 3. Then from 3, we go to 2. 2 alikuwa amepea moja, so it will be just 10 minus 4, and you'll get 6. So either you take normal or the crash, the critical path always remains. See if you create is 3, 10, and 12. It's the same. So now we have answered part 2. Part 2. Now let's go to part 3. Part 3 of the question was, part 3 here, the additional cost to be incurred if the project was crashed, 4 marks. The additional cost incurred if the project was crashed. So how do we get the additional cost? Now this how we get the additional cost. This how we get the additional cost. If the question asks about the additional cost, you need to consider critical activities. I repeat again. If the question asks about additional cost, you take the critical activities. If it's asked about the minimum cost, you have to consider both critical and uncritical. But for the additional cost only, you only consider the critical activities. Now, from our project, we have C. Our critical activity, we have C, we have D, we have F. So we have C, D, and F. Now, this is how we crash. So now let's be here. Tuanze na C. We are looking at the critical activities alone. So C, the normal time was 5, but the crash is 3. So how many days have we saved? We have saved 2 days. So for C, we have saved 2 days. Tukuja kwa D, 8 and 7. That means we have saved an extra day, 1 day. So today, we have saved 1 day. And from F, the normal time was 4, crash is 2. So that means we have saved 2 days. And if you add the total, you'll get 5. And that was the difference between 17 and 12. Then you multiply by the cost slope. Remember from the question, here we have been, we had already been given the activity cost slope. So C, here we have C. C is 30. So that means that for every activity of C, for every day saved, we incur additional 30. For every day saved in C, we incur additional 30. In this case, we have saved 2 days. However, it's 2 days times 30. That one you get 60,000. D, it's 60. The cost slope 60. Every day you save, you incur additional 60, but you have only saved 1. So it's 1 times 60. So you'll get 60,000. F, the cost slope is 75,000. For every day of F you save, you incur an additional 75,000. In this case, F, we have already saved 2 days. So it will be 2 times 75. and you'll get 150,000. If you add the total, that's 150. You're adding 150, then you add plus 120, and you'll get 270. So you'll get 270. Now that's the extra cost incurred if you crash the project. Good. So I hope you are clear there. We have said that whenever you are looking at additional cost, only consider the critical activity. Then you multiply by the cost slope. Good. Then part 4, explain the meaning of cost slope. We have already explained that, and then assumption made when crashing. Good. I think with that one, we are okay. So just a quick one. Let's try another question. Like May 2014, question 5. May 2014, question 5. Yeah. We do that. May 2015, question 5. We are told that, just let's follow this. We are told that it's already there in the screen. So let's follow this as you open. So the data below related to the activity of a certain project. We have activity A to H. You are given the normal time and the cost. Then you are given the crash cost, the crash time and cost, and then you are given the predecessor here. So required the project network diagram, Then number 2, the normal cost of the project, additional cost incurred if the project is crashed, obtain 2 assumptions made when crashing. So first of all, we need to know how do we draw the sketch? We draw the sketch. So we draw the sketch. So in this case, here we have the predecessor, always start with the predecessor. From the scratch, we have 2. So that means itakuwa. The first one, I'm a pair activity A. The second dash, I'm a pair B. Just put it here. Need to put it somewhere you can see it well. I think that one is clear now. So from scratch, there are 2 A and B. Then A, we have 1, 2. We have 2 A's. That's predecessor. That means A have predecided 2. That is C and D. C and D. Then B has also predecided 2. So amepea nani na nani? E and F. E and F. Then you are told that C and E wamepea G. C and E wamepea G. C and E. You see in this case, let's be here. C and E. You cannot cross. So what you do, just interchange them. Pereka D juu, teremsha C. So it will be CD. So that CE, CE, C and E washikane wazae G. And then DG, D and G washikane, so D and G washikane wazae H. Then with that, that's complete. But now H is hanging, F is hanging. So you should not leave your project hanging. So what you usually do, just join F and H. Washikania hapo. So that means how do we draw that? How do we draw that? So in that case, we already have a sketch there. So now let's draw a fair copy. Whenever we are having a crashing, divide by 2, or instead of dividing by 2, just draw them like that. But in this case, you have to draw two diagrams. So I think combining them is the easiest. So here we have A, here we have B. So in an exam, don't draw like the way I'm drawing. Use a coin. Preferred, use a 5 bob, the small one. Yeah, you see, that was just a sketch. So now that's the fair copy. And then you can call it 1, 2, 3, 4, 5, 6. I'll go marathon in this case. So the normal time, we have the normal time here and we have the cost. I just need the normal time. For A, it's 6, B is 3, C is 10, D is 4, E is 2, F is 3, G is 5, and H is 7. So it will be 0, 0. From 1 we go to 2. So it's 0 plus 6, you get 6. From 2 we go to 3. 0 plus 3, it's 3. From 3 we go to 4. 4 has 2 incoming variables. You take the highest. So it will be 3 plus 2 is 5. 6 plus 10, it's 16. So you take the highest, which is 16. From 4 we go to 5. 5 has 2 incoming variables. You take the highest. Like this one will be 6 plus 4, which is 10, and this will be 16 plus 5, which is 21. So you take 21. Then from 5 we go to 6. 6 has 2 incoming variables. Take the highest. 3 plus 3 is 6. 21 plus 7, you have 28. So you take 28. Also this one will be 28. Then you perform the backward pass. Then I can see someone is asking, is there a possibility we can be having 2 dummies? Even 3 you can have, Yeah, so for the dummies, they are not restricted. So you can even have 3, you can even have 4. And now let's perform the backward pass. From 6, we go to 5. 28 minus 7, you get 21. From 5, we go to 4. So it will be 21 minus 5, you get 16. From 4, we go to 3. 3 has 2 outgoing variables. You take the minimum. 28 minus 3, you get 25. 16 minus 2, you get 14. So that one will be 14. And then from 3, we go to 2. 2 had 2 outgoing variables, so it will be 21 minus 4, you get 17. 16 minus 10, you get 6. So the minimum is 6. So we look at the critical path. It can't be this, 6, 6. So we have that. So in this case, we have C, we have D. So which will be the critical path? Can you, critical activity there? Do we go to C, do we go to D? So can you type your answer there, C, D? C or D there? I can see C, C, C. Yeah, correct. It will be C. Because if you take 6 plus 4 is 10. This is not 10. It's not making any sense. But if you take 6 plus 10, you get 16. So that means you'll take that route. Then 16 upanda hivyo sasa. Because now 16 plus 5, you get 21. And then 21 plus 7, you get 28. So that's the normal time. Now let's do part 2 of the question. We crash so that we can see the shortest time possible. So in this case, 0, 0. So you're already given the crash time here. So the crash time, I'll just take this. For activity A is 2. Ziandike hapo juu. Activity A was 2. Activity B was 3. C was 6. Activity D is 2. Activity E is 1. Activity F is also 1. Activity G is 4. And activity H is 5. So now let's perform that. So from 1 we go to 2. So it will be 0 plus 2. You get 2. From 2 we go to 3. So it will be 0 plus 3. From 3 we go to 4. 4 has 2 incoming variables. Take the highest. 3 plus 1 you get 4. 2 plus 6 you get 8. So you take 8. From 4 you go to 5. 5 has 2 incoming variables. Take the highest. 2 plus 2 you get 4. 8 plus 4 you get 10. I mean 12. So you take 12. Then from 5 you go to 6. 6 has 2 incoming variables. Take the highest. 3 plus 1 is 4. 12 plus 5, you get 17. So that means the normal time was 28, but the crash, if you crash, you can be able to divide it you can be able to finish within 17. So I can see someone is asking, if I can divide the event node into 4, why do I need another diagram during exam? I've said that if you divide by 4, you don't require 2. If you divide just by 2, that's when you need to draw 2 of them. Like this for the one I'm showing in blue, you can draw it as a separate diagram. But in case you have divided into 4, it's like you are just combining them. If you write them into 4, you don't have to draw another one. If you divide them into 2, yeah, that's when you draw 2 of them. I hope you are answered, Agnes. So now let's perform the backward pass. So 17 minus 5, you get 12. From 5, we go to 4. So it will be 12 minus 4, you'll get 8. From 4, we go to 3. 3 amepewa wawili. So that means you take the minimum. 17 minus 1, you get 16. 8 minus, this was 1. 8 minus 1, you get 7. The minimum is 7. From 3, we go to 2. So can you give me this? Answer me this. Give me the answer for here. Hey, type your answer there. Sitamwambia tena. I can see my students are following. That's so impressive. Yeah, the answer is 2 because it's 12 minus 2, you get 10, or 8 minus 6, you get 2. So the minimum is 2. Also, if you crash, the critical path remains the same. So the normal duration was 28, the critical is 17. So you are through with that. So part 2 of the question was, so the project network, then number 2 was the normal cost of the project. How do we get the normal cost? So this is how we get the normal cost. You just add the total for the normal. That's 50 plus 40 plus 40, 10, 15, 40, 70, and 80. That's how you get the normal, the total normal cost. As simple as that. Now let's go to part 3. Part 3 asking about the additional cost incurred if the project is crashed. Additional cost incurred if the project is crashed. So how do we get that additional cost? How do we get that additional cost? This is how we get the additional cost. This is how we get the additional cost. We have said that for the additional cost, you focus on the critical activities. And in this case, our critical activity, we had A. Our critical activity, we had A. Also, we had C. Also, we have G. And we have H. Those are our critical. Twende kwa A. A, 6 and 2. To me save how many days? Those are 4 days. So A is 4. C, 10 and 6. We have saved another 4 days. We have G, 5 and 4. 5 and 4. That's the normal time and the crash time. We have saved 1 day. And lastly, H, we are looking at the critical activities only. So 7 and 5, we have saved 2. Then you multiply by the cost slope. We said, how do we get the cost slope? We said that to get the cost slope, you take the change in cost over change in time. So let's get for A. We get for B. I mean, it's AC, it's A, C, G, and H. We're only looking for the critical activities. Tuanze na A. Like for this, what you do, cost was 50, the normal, but if you crash, it's 100. So that means change imechange na ngapi? It's 100 minus 50, which you get 50. Then you divide by change in time, na ndio hii imechange na 4. That means 6 and 2. The change in time is 6 and 2, which is 4. So that one you get 12.5. Let's go to C. C was also critical. If you go to C, the normal cost was 40. If you crash, you incurred 120. So the difference between 40 and 120, I think it's 80. So the change in cost is 80. You divide by change in time. C, to may save 4 days. So that one you will get 20. We have said 4 days. This is what I mean. 10 and 6, the difference is 4. Now, the other critical activity was G. You come to activity G. We have 70. and we have 120. The cost, the normal cost was 70, the crash was 120. So the changes is 50. The change in cost is 50. Na G tumeona we have only saved 1 day, divided by 1. So that one you get 50. H, change in cost, 80 and 200. So that one becomes 120. You divide by change in time, which is 2. Or change in time, this is what I mean. The normal time was 7, the crash time was 5. It has changed by 2. So you divide by 2. So this is 60. So tumesema to get the additional cost, you take the time saved, you multiply by the cost drop. That means for A, for every time you save, you are incurring 12.5 extra. So 12.5. C, we have seen is 20. G, it's 50. H, it's 60. So this one you get 50, 80, 50, 120. So that's 200. So you get 300. That's the additional cost. So additional cost to be incurred will be 300. Then last three, number 4 was outline to assumption made when crashing. We already have them, eh? The time and nini, blah, blah. Yeah, so there were 2. So from the handout that I had already sent, but those who are not received, they'll receive it. Eh? I have done other extra illustrations. Eh? So that one will help you. So in case you have a question, you can post it. So I'm hoping now you have gotten something. So that one becomes the end of our today's class. I hope you have got something. So kindly make sure you are revising. The notes have been sent to you. I have summarized them, then have done more illustration than what we have done in class. Eh? So kindly go through them. Then remember tomorrow, for those who are doing auditing. So tomorrow you're having a class on audit. So don't let yourself pass QA and then you pass on audit. Eh? Or you fail on audit. You pass QA, you fail on audit. So kindly purpose to attend tomorrow. Then another thing I said before I start the class, on Monday it's a holiday. It's a holiday on Monday. So on Monday, I want to schedule a class from 4 to 6. Monday is a holiday, so we schedule a class. We'll be having a class on Monday. That's from 4 to 6, so that we can be able to do linear programming. So next class, God willing, can do linear programming. Remember, linear programming is one of the widest because as transport, as an assignment, so we need to utilize on that time before the exam gets us off guard. So kindly attend tomorrow. Tomorrow we have auditing. Then on Monday, we have said that we have another QA class on Monday from 4 to 6, God willing. So kindly keep safe, and then I wish you all the best, and then you may have a good night. Good. Then before, let me first of all answer some questions here before we finish that. So I can see Penina kindly said the notes, the handout for the topics today. So I already have sent. I sent. Number 1, I sent to we have a group we had already formed. So kama hujapata hapa, you can contact, either you can contact me or you can contact Mr. Moremi, or where you paid, just text the person you paid to. You'll be able to get the notes. Yeah. So I have already sent the notes. So, but in case I have not sent, you can just text me directly, or you can request them from the groups. Those who are asking about how to join the audit, the time will be it will be from 8:30. 8:30, you just pay 250. Just pay 250 shillings, and then we'll be able to send the login credential. Yeah, you can contact me. I'll give you the till number you pay. I think I have answered. Someone is asking if they can be able to get the recording for this class. In case you have poor connectivity. Yeah, and you had paid. So kindly you can contact me or Mr. Moremi.